Good morning, everyone. Today, I'll be presenting how hydrogen can potentially be used as an alternative fuel source to drive our transportation industry into a new era of hydrocarbon independency. So here is a brief outline about what I'll be covering in today's presentation. Before moving into hydrogen, it will be very beneficial for us to recap what hydrocarbon is. Hydrocarbons are organic compounds composed only by carbon and hydrogen. The carbon atoms join together to form the framework of a compound, and hydrogen atoms attached to them in many different configurations. This family of compounds is currently the principal constituent of petroleum and natural gas, and so are their process products like jet fuel, petrol, and diesel. Hydrocarbon is by far the dominant energy source for the transportation industry. According to U.S. Environmental Protection Agency, hydrocarbon contribute to 97% of energy used in transportation. Needless to say, hydrocarbon has proved itself to be highly commercially viable through centuries of evolving adaptation. However, such success it's not so glamorous when considering the environmental cost. As we all know, carbon dioxide is a natural product of all hydrocarbon fuels after combustion, and CO2 has been repeatedly proven to be the most significant contributor to climate change. According to IPCC, Intergovernmental Panel on Climate Change, around 14% of total carbon dioxide emission is generated during transportation. After understanding the problem, now it's just time to introduce hydrogen as an alternative strategy. In order to replace hydrocarbon fuels, hydrogen itself must be an ideal fuel at first place. Compared to traditional hydrocarbon fuels, hydrogen has a much higher energy density or caloric value. It can produce almost 3 times as much energy per unit mass as traditional fuels such as natural gas, diesel fuel, and gasoline. It means that motor vehicles can achieve the same power output by carrying less dead weight of fuel. Perhaps the most eye-catching advantage for hydrogen is its minimal environmental impact after combustion. The only product hydrogen produced through combustion is water, which is environmentally friendly and can be easily recycled. The replacement fuel for hydrogen need to have the replacement fuel for hydrocarbon needs to have sufficient storage on Earth to satisfy the demand of the public, and hydrogen indeed satisfies this requirement. 13% of atoms in Earth's crust is hydrogen, and most of them are in the ocean bounded in water molecules. So here we can perform a simple calculation. This data from National Geographic. If we take the volume of the ocean and the percentage molar mass of hydrogen presented in the water molecules, there are about 1.61 times 10 to the power 17 tons of hydrogen inside ocean, which is more than itself what we need. Choosing hydrogen as a future power source also have social political advantages. Hydrogen has already been recognized by House of Parliament and an advisory council has been established. Germany has also announced a 9 billion euro investment in hydrogen. Apart from support from public sector, private corporations from energy and automotive industry have also invested in hydrogen and have made some engineering breakthroughs. Combining public and private support, the outlook for hydrogen looks positive. However, hydrogen still faces some very serious practical challenges. The top obstacle is the cost. As an experimental fuel source, hydrogen does not benefit from the economy of scale like hydrocarbons do. We can infer it from a blog post on Clean Technica. The cost of using hydrogen is about twice as much as gasoline for a normal consumer. It's about 5.5 over 2.5. Switching to hydrogen on a countrywide scale may also have social challenges. Recalling the Yellow Vest movement taken in France back in 2018, a small increase in fuel tax led to a widespread social chaos. Switching to hydrogen costs twice as much as gasoline for normal consumers, and it might have an even stronger social impact. The last but not the least, hydrogen may not be as clean as it seems. There are no doubt that hydrogen only produces water after combustion, but producing hydrogen involves extensive use of hydrocarbons. According to research done by Istanbul Technical University, 96% of hydrogen produced directly come from hydrocarbons. So, in conclusion, hydrogen is a fuel source which has great potential to power our transportation. It is dense in energy, clean after combustion, rich on Earth. This characteristics has attracted a lot of support for it. However, the cost is still the core problem and may lead to more unforeseen social impacts. The environmental impact also need to put into careful consideration.